This is Torrance Stewin with Lab 3 Constant Velocity Motion. Our observation was a rolling orange just on carpet. We were looking for our main result to be our assumption that FNet equals 0, and our model provides good predictions of our observed motion. Here in Tracker you can see that we've uploaded the video of our orange. Over here you can notice that I've used the origin as my beginning point. Also chose the x-axis and oriented it so the orange would just move along it at a constant velocity. I took the center of the ball and marked it as the average position. Here it's shown my calibration stick also to measure the diameter of the ball, and I set it up as the leg scale of the video, which was 0.05 meters. So as you can observe now, there's the ball moving just along the x-axis. My time between frames was 0.3033 seconds, and the time of the whole video clip was about 1 second. Once we've got a look at that and we've got all of our data points from that, I go over here to BPython. The mass of our orange was 0.04 kilograms, as shown right here. Our initial position was 0.001 and ending at 0.579. Our delta t was 0.8 seconds. Here is where I'm finding the velocity, which I got 0.7225. All of this was taken from my tracker data. So as you notice in BPython, under my initial conditions, I put my initial position right here, and as my final velocity, I've put it right here based upon my calculations that I've used. Down here, my time t is 1 second. My FNet vector is shown right here, and XYZ are all zeros. The FNet has to be 0 because we know that m is not equal to 0 and delta t is not equal to 0. So this is going to predict the motion based off our initial condition. So as I run this module, there we notice the ball moving. Our graph is showing that it's increasing and with positive values. So now we ask the question of how was our tracker data compared to our model data. So right here we have, we know that our x is measured in meters and that our t is measured in seconds. The blue line is shown as our experimented values, and the red line is showing that our model values. This model just predicts the observation of the entire range of observations. So there they are compared to one another. So now we ask the question of what if. So if we had something moving in the negative x direction and to the left, how would that change? So to do that, we go back to our VPython program, and we actually just set these to negative. We just set our initial position to negative, which would end up being an initial, or our final velocity would be a negative also. So if we run that module and compare it to the very first one that we had, we will notice that it's moving in the opposite direction. Also, our graph shows that as time goes on, it gets negative as it advances, just shown right there. So that kind of answers the question of what if it was moving in the negative x direction. Next, like what does all this mean? We know that our FNet is equal to 0, as shown in our program right here. So our total pushes and pulls are equal to 0, which implies that our FNet of 0 is constant. So to change the directions, we just kind of change these to something other than 0. We run this module, and you can see that the graph of it changes and goes up and changes direction and speed.